Okay, so this is a small digression, just going into sort of a tooling discussion of the comparisons between these two USB mice. And basically the sort of simple differentiation between them is this is obviously a bit more of a premium product and this is a cheap one, regardless of its actual electronic complexity. So if you take these two, you can see things like they both have bosses which stand up and hold on to the scroll wheels here. However, you'll notice that with the more expensive one, there's obviously a lot more reinforcement and things are very sturdy, whereas here it's a little bit less reinforced, a little less attention has gone into it. But arguably it's still perfectly adequate, it does the job. The other thing that you'll notice is, aside from weight, even when you haven't got the batteries in, this is arguably a lot lighter and this just feels a lot more sturdy, and you can see there's more ribs going down the side. And giving things sort of ribs and details where you combine features like this is just a little bit of an indication of someone who's frankly had the time and inclination to do these things to that level. So a few other things to look at which are quite interesting is this little pocket will have been taken from two pieces of the machine tool coming together and what's called shutting off an area, which means the plastic can't go in there, and that means you have a sort of see-through hole. Interestingly, it's just so that it fits the USB dongle. It does mean that you can see the inside of the product, which perhaps, you know, the person who designed this felt that it was better to have the economy of losing a little bit of plastic than having a sort of stronger aesthetic, perhaps. So it's interesting, sometimes with very cheap products, you sometimes get an interesting rationale on why things are economized. And it's not always a negative thing to have a look at things critically in that way when you are designing under a budget of what really needs the money to be spent. So another thing that you'll see is that in these areas here and there, you'll see we've got these little, I'll maybe draw them on with a line just to highlight it, and that you can see that there's these little areas here and here, and the same with them there. And what that is basically a tooling action that allows a piece of metal to go underneath something that wouldn't be able to pull apart naturally. So if we have a sort of little diagram of these naturally in cardboard, then in order to achieve that overhang, you wouldn't be able to have something come down and stay there and then try and pull away, because obviously it would get stuck. So what actually happens is that it comes down, slides in, and then is backed up by another piece of material. And then similarly, when it's reversed to release the part, once it's been formed, it will come apart in two ways again. So basically those are called tooling actions, and obviously this is a gross simplification for anyone proficient in the business, but the thing to sort of appreciate when you're in the sort of beginnings of your design is the more tooling actions you have, generally the more cost you're going to incur on your machine and your part. And of course, with every fiddly little action you make, it also means that the tool is more susceptible to wear and tear. So another nice little detail is that even though this is the more expensive one, you can see that they've made a pretty substantial screw boss, which is good because it gives the component good assembly. However, what it means by having a sort of irregular thickness is that you get these two little sinkholes, which is where, because the material is thicker, it's taken longer to cool than the rest of the part, and it's sunk in basically as it's cooled. Now, I guess you can say what's kind of clever about this is they've done this on a part which has no visual consideration for the user, so arguably it's completely alright. And you can tell that from just looking at the two of these, this is say like a spark eroded finish, which gives it this nice matte finish, and this is sort of a very low quality polish, and you can see that it's even a bit scuffed up, and the tool hasn't been especially well looked after because, again, it's not a visual component, it doesn't really need to have that detail given to it. So again, one of the other things you can see is there's like often a little hole which has a sort of snapped small dot of plastic, and that's basically where the plastic has been fed into the part and then it's dispersed throughout the cavity in the mold. And what's interesting to realize is that you can't always fill larger parts just with one point. You maybe need multiple feeds. And of course, this is a very easy feed in that it's with the part that it comes apart. So again, these are sort of things that you can go into more detail, and I'll upload a PDF of a very, very detailed industry document. But really this is just to give you a bit of an indication of what you're looking at when you see various components. And another thing that you'll see often are these rather sort of unsightly dots, which have these sort of crude filed edges almost looking to them. And that's actually where the pins will come out of the mold and push the part out of the injection mold and presumably into a hopper or to be taken away. And again, this is another design consideration, that if you make something in the mold, when they come apart it'll stick to one side, and so you'll need to push those out with the pins and release it. So again, this is just something to bear in mind when you're going through the design process on, can you do something all in one part, or can you do it in 2 parts, 3 parts, and have a different assembly. So these are all the experience sort of gained things that you develop over time, but it's interesting to know what you're looking at when you take apart a simple product like this. So I hope that's useful.